Okay. Video's uploading. Alright. Bit manipulation with bitwise operators and bit masks. Okay. Standard bit set. Alright. Yep. We apply them to each operator, but we don't choose each one. Well, because the logical operators are. I mean, those are left shift, right shift, and or not, and XOR. So they do operate on each bit within the operands, but the operands themselves are not bits, not individual bits. Oh, bit masks. Okay, that's cool. Just stop sitting like this, I think. Okay. I mean, because I can do this currently under bit sets by using test and then the position, or set and the position. Set, reset. What is it? Just set and reset? Set, reset, flip? It's too hot. It's about to be hot. Gotcha. So like cover 3 bits and then set the whole bit set, I guess, whatever we call that sequence, update it. So like if I have 4 zeros and I want to set the last one to be 1, then I set them all to be 1 after applying the mask. Then the only one that this can touch is the leftover one. Hmm. So I could probably do a bit mask to do the same shit that we were doing in the last one. So instead of shifting this bit set 3 times or well, shifting it, doing a shift 3 times to move the first, whatever, the first bit to the last spot in order to then include that with another and do an or assignment, or in order to do an or assignment to give a bit set to include that last thing and overwrite that the main bit set. Instead, we could just apply the mask and then just say, hey, get the only bit here, set it here. I don't know how simple it'll be though. And allows access to the ones we do want modified. Okay. Okay. Jesus Christ. Yeah. Oh, okay. Hmm. Oh. One, 2, 4, 8, 16, 32, 64, 128. Gotcha. That's easy enough. Hmm. So we're basically checking if the actual bits that we have match what the bit is. So if this one and whatever, well, let's see. Yeah, because it's automatically on in the mask. So if we compare the mask to it, and we check the mask after, because if this is already false, if not flagged, then we already know. Actually, no, that's not how this works, I don't think. It still compares everything, so it's going to compare flags and masks 0. So if it doesn't match, then it's off. Again, if it doesn't match, it's off. So it'll compare this guy. So it'll say on because that's bit 1, bit 0. That's bit 0. They match on. And we know that the masks are on. So if they don't match, then this guy's off. So we know that if the second one is off, doesn't match this one, then off. Okay. Excuse me. And the point is that you're saying this and this. This is the bitwise operator, the bitwise AND operator. Means it gets this. Oh, yeah, the point is that the mask only has that one bit. So if that one bit doesn't match, we know that none of the others are going to match. So we know that the answer is either 0 or 1 when we compare something to the mask. So if we have 8 bits and we compare and we compare this to this, we expect at most to only get 1, 1, 1. And it would be where they match. But if we don't get one there, then it doesn't match this position. That position doesn't match, nor that one, whatever. So it's either 0 or 1, so we cast it to a boolean. And we say is this conditional arithmetic ternary operator is all parenthesized because it's in a complex statement, complex expression, something like that. So it says on if it's on, off if it's off. If it doesn't match. Okay. Yeah, so to turn it on, we return the or. So we'll compare whatever. We have something. Let's say it's 1111 1111 1110. And then we instead change it to be, we assign it to be the or the return value of or with the mask for the last position. Well, the mask for the last position is 1. And or will return exactly what the bit sequence first, or what the bit sequence is, but then whatever the mask, but with it being 1 or true for wherever the mask position is too. So if the last one is 0, but we want to change it to 1, well, once it is assigned the OR value, the position that is true in either case, turns out it's only true in the mask case, is updated in the real case, the flag. Yep. So we're assigning it the OR. Okay. This or this. We have 4 and 5. This yields a sequence of 0, 0, 1, 0, 0, 0, 1, 0. If the first one was 0, 0, 1, 0, 0, 0, 0, 0, and the second one was 0, 0, 0, 0, 0, 1, 0, 0, or 0, 0, 1, 0, something like that. This getting assigned the OR value would then be turning on both of these, because it would have, if both of these were off, well, it would yield a bit sequence that is true for both of these compared to this one, which gets assigned to this one, so it gets turned on. Excuse me, to reset a bit. So if it's on, the AND value is true. So assigning flags to be the bit sequence of flags in mask 2, it wouldn't change anything. Or actually, it Hmm. So if we're assigning it to be whatever doesn't match mask 2, if we know that bit 2 is already on and we want to turn it off, then we want to keep everything else that doesn't match mask 2. So we assign it to be whatever is true for not mask. So we take not mask, so it's everything is 1 except position 2. And we check and then we have this other sequence that we create by comparing those and seeing which ones they have in common. In this case, the only one they'll have in common 0000, 0101, and 00 and 1111 1011. The only one they'll have in common is not the first, second, or not the seventh, sixth, fifth, fourth, third. The second will now be off because 1 and 0 don't match. So we assign it to be what? Yeah, we assign it to be the comparison result. So when we compare, 1 here does not match the 0 there, so we get a 0. And then 0 here and 1 doesn't match, but 1 and 1 finally matches. Multiple, the mask 4 or 5. So we yield multiple, and then we flip just those, and then we compare to just those. We assign whatever doesn't match those to be here. Well, by definition, we should already every bit except 4 and 5 should not match those. So we turn off 4 and 5. Yeah. Yeah, so just static cast it back. So whenever we operate on whenever we use a bitwise operator on something smaller than a 16-bit int probably, or on like a on something smaller than 16 bits, yeah, then it's likely that we need to static cast it to whatever it's supposed to be after. Yep. To flip it, we use XOR, meaning if it's only true in 1. So if we see that it's 0 here and it's 1 there and it's only true there, then we flip it. Okay, makes sense. I'm not going to use these, so I'm going to go through these quick. Simultaneously being this or this. And if they match, then it won't do anything. Or if they match, then it'll return false. If they don't match, it'll return true. Now let's see. Something like that. Dude, eating an entire bag of Doritos Sweet and Spicy yesterday was not the play. Oh, true. Yeah, because I'm going to have to set this and then set that instead of just comparing it and equals to whatever. 4. Yeah, that makes sense. we want to evaluate it, we can check. Check me in is happy to see if they match. Is it a 0 or a 1? Should be a 0 if they don't match, or 1 if they do. Okay, since I'm reading, I'm gonna go back to stretching. I need to stretch the different way. Like, oh. Well, no, I shouldn't be doing static stretches. I should just be doing a bunch of stuff. Excuse me. Oh. Oh. Got any to see if any are true. Or oh. And that. That and that. The only, it should return true since it's only comparing those. So it should be, everything should be false except is happy with your testing. And if we said dot any, if any of them match, then it means that you're happy. Otherwise, any. Yes, exactly. Hmm. So you have one mask per state. Each state is the Boolean. So there's a big. Well, yeah. So if we're talking about a byte, there's only 8 states, or up to 8 states. Then, well, it doesn't even have to be 8. It could be. It could be more. You had 100 people, meaning you had 100 of these. They each all have these. You'd have 8 and these. Instead of storing all of these in person, instead of having to have me hungry, me sad, me mad, etc., you just have all of these and you compare them to these, and you update them in me using this integer to store 8 booleans within it instead of having to do each. Yeah. Yeah. So instead of having, okay. Yeah, it makes sense for simulation, maybe. Okay. Yeah, instead of just passing it the fucking flag, the bit flags, have it be a 32-bit set. So the point is that for a bunch of different conditions within, yeah, it's gonna be better. It's probably better. Yeah, Blueprint definitely doesn't automatically make it like this in Unreal. That's for sure. Then you just pass it the bit flag. Or just pass it. Oh, meaning a function that takes those. Oh, and then I just get them. What if I wanted to get them? Hmm. Yeah, so I guess we could just return it compared to the mask. Let's see. Oh, fuck me. It is quiz. Hmm. Because this is in hex, and each one of those represents four bits itself. Because 16. It's four of them, four of them, four of them. Yeah. So we're taking it this long 32-bit number, it's unsigned int 32. Shifting everything down. Last 8, 24 back. The 8 before that, 16 back. The 8 before that, 8 back. And then the first 8, not shifting at all. And then when we cast that static cast it to be an int, it removes the leading zeros. So we end up with, well, actually, it just converts it into decimal. Oh, actually, never mind. It's printing them in hex, so it's the last 8, and it's going to convert binary to hex. Well, actually, no, because it still stays in hex. No. It is staying in binary. It's in binary, and then we're printing it as hex. Yeah. Yeah, because it's an int32. Taking pixel and red bits, which are also uint32s, which we're then shifting, and then we're casting to uint8s, which cut them down to size. Then we're just printing the hex. We're comparing pixel to red bits to only store, or to only keep, or to get the red shit that we care about, and everything else should be zeroed out. And then we shift it down 24. Okay. And the reason this works is, let's say option 4 is the mask for the final position. Let's say it's the 7th position, which is really the first number in the bit sequence, or the bit flag number, whatever. And should return, the and will return this bitwise and this logical and operator returns the bit sequence where something is true in both cases. In this case, it'll only be true or it'll only be false in that one spot. So it should only return true if flags has a true value there, because in option 4, the mask, it has to be true because it's our mask. To set them on, we use the OR. So we set it equal to OR cause. Anything that is already on in the flag will be off, or so anything in the flags variable that we're storing bits in, that we're using to reference, we're using to store bits, individual booleans. Should be, or anything, the flag can be whatever it wants, but there's only one in our mask, and it's the number that we care about. It's the specific bit in the position that it cares about. So it's the 4th one, a 5th one, a 6th, a 7th one, which is the last one, the 8th, but 7. So we use OR assignment to assign the one similarity, or the one, not the one similarity, but the one where it's true in both. So there's only one true in the mask. It's only going to be, so it'll be true It's true guaranteed because it's the mask. So we're assigning it to be true. Turn things on using that. And in this case, we do option 4 and option 5, which gets 2 bits on in the 8-bit sequence, or the more than that sequence. Then we are assigning it to be the OR result, which is automatically going to turn on whatever positions those are. Turn them off, we use the AND assignment and the NOT operator. That's because if we do not option 4, everything is on except position 4, which means if something is already, let's see, means the only thing that's going to be off is the position that the mask is made for. So like, let's say it's option 4. Well, anything that's already on in our flags is going to stay on because we're setting it to be and not. So once we've flipped it to be not, all of our ones will stay ones. But if we have a 0 for option 4, then it will turn on. And if we have option 4 and option 5, that turns it from being all zeros and 1 1 to being all zeros and 2 1s. And then if we flip that to be not, then we set ours to be 1s for everything that is already 1, but 0 for the ones that we don't want. Flip them, we use XOR. The reason is because if we have all 1s and the flag is position 0, so it's 7 zeros and then 1, let's just say 3. Position 0, so it's 0 0 0 1, then we have 1 1 1 0. We want to flip the whole thing. We assign it to be the XOR result. The XOR result returns 1s whenever there is an odd number of true statements for one position. 0 and 1, that's odd. 0 and 1, that's odd. 0 and 1, that's odd. 1 and 0, that's odd. Or hold on. Oh. I have to draw this out. So this is the mask. I don't understand how this flips. Oh, am I fucking stupid? Of course I am. So if we do it here, this only turns on one. The point is, if we want to turn on all of them, then we have to do or 0010 or 0100 or 1000. And that makes all of these 1111, which means 1 and 1, that's false, 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 true. Okay. So it was only making sense here. This would only flip once. If we ran this, this would be 1111. But then we'd run the second one. Or we would do a big OR, and then we do the XOR, or XOR. XOR. Okay. So we use XOR. So if we had 1110, maybe we need to flip 0. We compare it to position 0. And position 0 is 1 in the mask, but in the flags it's 0, which means 0 and 1. So it goes to be 1 because there's only one that is true. Flip. An odd number that are true. No bit set. One question. We'll start with the extra credit. The reason these are the same are if we assign the flag to be what matches between it and, if we combine option 4 and 5, and then we do option 4 and 5, it'll be 0010100, something like that. Yeah. Which means there'll be 2 1s, and if we flip it, there'll be 2 zeros, and we'll set it to be whatever matches. So everything that's already a 1 will stay a 1. The only things that are true in our flag that we're turning off would be, there'd be zeros in the flag that's knotted, so then we assign those, so we get 0 and 0. Just like if we say not option 4, which is all 1s and 1 0, and not option 5, everything is true except for the 2 zeros because they don't align perfectly. So not or, because we've combined those 2 masks and then we're taking the not, versus combining the 2 not masks. Not this mask, not this mask, and will get us not this mask or this mask. See, we're saying not this mask or this mask. We combine those masks, take the not, versus taking the not. Yeah, it's the same shit. Why are they the same shit? I mean, it's just how the logic works out. It's like, why is 2 plus 5 the same as 5 plus 2? Because we have 2 and then we add 5. Because we have 5 and we have 2. And we count in our hands how many we have at the end. It's the same shit. Okay, I need to lock in. I was getting a stupid frame of mind where I was thinking, oh, okay, this stuff isn't particularly relevant. I'm just trying to get like the main backbone here of programming. Excuse me, in C++. So I don't really need to deal with the bit stuff right now. But the point of this, the whole point of me learning C++ is so that in whatever, in some small number of years, I'll be in that VR industry. And in like 10 years, I'll be a big dog. But in order to do that, I'm going to need to be able to do anything I want at super low levels without having to ask AI to tell me everything. No vibe coding for me right now. Because it's probably pretty likely that I have to work at a low level, do manipulation, in order to optimize things, and I'm going to need to become my own kind of expert. And then if I need to do everything at first, and then if I end up not needing some things, okay, cool, I can consult with some specialists to do something for me. But I need to do this stuff on my own. Okay, what does it want me to do? Excuse me. Oh, this is that. What's that? This is 8 plus 4 plus 2 plus 1. Isn't that 16? I think that's what these are. Okay. So we've now set it to be that. Add it to set it as viewed. And so we're saying my article flag, which is this, option viewed, which is this or this, which means none, one, putting them together like that. Oh, is it bugging out? No, we're good. Need to lock it and do this because I'm gonna need to be able to do everything, especially if I'm just getting a job somewhere for C++. So I can't just be like, oh, I'm not gonna do that because it's not particularly relevant. That's like me. That's like me just staring at Unreal all day and working in there, and not touching C++. I'm doing C++ to get a fucking job, and because it's gonna be needed in the future. To check if the article was deleted. To set it as viewed. To check if it was deleted. So we need to say cast it to a bool. And what are we casting? It's just this and this, right? To check if it was deleted. Hold on. Oh, oops. Not deleted. If I instead then it would be true. Because we would be adding the or. The or option deleted, which means we would be flipping. This seems like one of the things that you just do and then you just understand because. You're like, oh yeah, duh. Or assign means that we are not flipping, but we're setting this guy to be true. Why? Because we're checking what's similar between them. So the only thing between them should be the one that. Hold on. Excuse me. So we're setting option viewed. Why? Because when we take article flags and we take option viewed, we are assigning this guy to have all values that are true in either of these to be true here. We're assigning it the true values shared by either. And because this one has it true, even if this one doesn't, it's true in both, or it's true in one or the other, so boom. checks if article checks article was deleted. Why? Cool. To clear the article as a favorite. So we're setting it to be only those that are shared between it and something, which means we can do and assignment. What do we call this? I don't know. I'm going to look for it after. My article flags and option favorited. So this will take option favorited. It will take article flags. And it will... Oh, hold on. Not this, because this is not right. This is going to be false for basically everything. And not... So this is or... Hold on. We want to assign him everything. Everything that is shared between him and not that flag, so that we turn it off. Turn just favorite it off. We want to turn favorited off, or unset article as favorite. So it's my article and not option favorited. And this will say option favorited, which is this guy, and it will be 1111 1011. And everything that is true between them hold on. Alright, I don't need to do this. Maybe I do? Hold on. This is redundant. So it's not deleted, and it's 101. First is 1. Then we're setting view to be true. We're setting it to be this or this. So these compound operators, whatever we call this guy, let me see what they're even called. Bitwise assignment operators. Okay. to unset it as a favorite, we're going to set my article flags to be I think it's that. I think I already had it. Yep. And the reason this works is because we're taking option favorited. Jesus, dude. Talking a lot, I guess. And we're flipping it so everything is 1 except the second position. And we're assigning it to be and, which means we're assigning it the binary sequence of things that are only true between both. So even though this probably has a bunch of 1s that are not 1s here, we're only assigning them to be 1s if they're true in both. So in this case, since we flipped it, there's a bunch of 1s here, and we don't want those to be true here. So we assign it 0s because it'll be 0, or so these are a bunch of 1s. So it's 1, 0, so it stays 0. 1, 0 stays 0. 1, 0 stays 0. 1, 0 stays 0. 1, 0 stays 0. 0, 1 goes back to 0. 0, 0 stays 0. 1, 0. Or actually, no, it's actually 1, 1 stays 0. And this is actually a 1 and a 0, so stays 0. So I need to draw these out, man. I hate having to draw stuff out. I feel so stupid. 1, 1. So, excuse me. If we have 1, 0, 0, 1, 0, 1, 1, 1, and I want to turn this guy off, we have a bit mask. Here, the bit mask. And so what we do is we flip him, or sorry, we flip him. So 1, 1, 1, 1, 1, 0, 1, 1. And now we assign this guy through and comparison with this guy. We assign him, assign through and comparison. That stays 1, 0 and 1, that's 0, 0 and 1, not true in both, 1 and 1, that's true in both, 1 and 1, that's true in both, 0 and 0, or hold on, wait, hold it. 1, 1, we want this guy to be off, so yeah, so 0, 1, that's off. We want not 1, 1, 1, we want 0, 1, 1, but now it's 1 and 0, so we flip this guy. So this guy goes to 0, and then 1, and then 1. All right, it's weird. It still doesn't feel intuitive, but that's the right way. Does this by updating my article flags, or by updating flags variable to only what matches to keep everything already true, true. And to make false what it has true that isn't true in the not mask. Okay. Spoken like Kamala Harris. Holy shit. Alright. To clear the article is a favorite, so now it's that. And extra credit. Wow, I'm surprised I did those. Okay. Without having to go and reference and look at the shit. Why are the following two lines identical? This or this combines them through just how the operation works. And if we take the not, and then we assign it to be what matches the not, everything that it has true stays true. Everything that it has false stays false. Meaning that since we flipped this, instead of it matching the mask, it matches the not mask. And here, instead of having to do 3 operators, here, we're doing the shitty ones here. So instead of doing 3 like this, we do 2. Well, I guess it's actually even more. So maybe not, but. So we're saying not this or this. So not option 2 or option 3. So we turn option 2 or 3 off, or 4 and 5 here. So if we have option 4 and option 5, not, we have 2 masks with a bunch of 1s. And if we combine them, the ones they don't share, which is option 4 and 5, one of them has it off, one has it on, the other has the other one on, the other has the other off. We combine them so that both of those go off because they don't match both. And then for here, we match it, and everything else that already doesn't match, or everything else that's already a 0 stays a 0. Everything that's already a 1 stays a 1. But the things that don't match now, so like if we had 1 and, or if we had 4 and 5 on, 4 and 5 on matched their masks. Option 4, position 4 is on in its mask, position 5 is on in its mask, but if I flip these, now they're off and off, and if we assign our flag binary sequence variable to be the result of the AND comparison between it and them, then they're on here, they're off in 4, or in 5 and 4, or in position 4 and 4, and position 4 and 5. 4 and 5. So now, 1 and 0. It's now 0. 1 and 0. 0. Oh, man, I'm so stupid. That was hard. I think that's it. Is that 6 hours? Let me see. Let me check. Fuck it. That's it. That's more. More than 6 hours of coding today. That's when my brain is fucked. All right. So I think I'm gonna switch to doing. I'm just gonna come home from work and eat, and then sit down and grind this shit because I have to learn. It's like, it's just annoying because it's not physical. These mental things are so hard. Like, if I got a golf club and then I put a virtual screen on the side, and then I got a mesh. I can't even think the amount of words I've said today. A mesh net. Like, what's the word for the elastic thing that catches things? Net, motherfucker. Oh my god. I got a big screen and a net and this little bit of like grassy whatever here that I can hurt without it hurting the floor or anything. And I swing this golf ball and the net catches it over and over, and I put it at the wall so it doesn't hurt anything. I'll put some kind of foam up so it hits the foam and doesn't hurt. And I'm up here and I'm just swinging that shit all day. Eventually I'll see physical improvement. And sometimes I'll just get lucky. But with the mental stuff, like I could throw an axe 10 times, and odds are out of my first 10 throws, I'm probably going to hit it one of those times. Without having to sit and think about it a whole lot and work it out on paper. I just do the physical thing. And your body just learns and is able to just adapt. Just like throwing a spear at a deer. If I do it a bunch, eventually it will happen. Even if I'm not like really agonizing over it. But here I'm agonizing over it and I'm sitting down for hours looking at a screen and just thinking and then writing stuff out. And then finally it clicks. It's just the payoff for throwing a spear at a deer is eventually, like within a couple days, I hit the deer. But the payoff here will be a job down the line. There's no short term, like there's some short term, woohoo, I got it. But it's not, I mean, I got it without having any of these be wrong. But oh, let me actually check those solutions too to see what they did. Or what Alex did. He did. Yeah. So we're setting it to get anything that is true between them true. So anything that's already true stays true. And then there's going to be one that's false here, but it's true here. So we save that too. And then we have another one here. And we say, add a line to check if it was deleted. Oh, well, I'd rather just say article deleted, false. Or we can just say if oops. Move the escape sequence. Cool. Oh, hold on. Why was this okay? Oh, because not option favorited. I'm surprised it was actually cool with it. I think I just got lucky here. Because not option favorited should be taking this UN8T and converting it into something larger and then reassigning it here. So this should really be parenthesized. And then this should be a static cast to a uint8t. Like that. In order to remove it. And then if we add it, it's already there, technically. So, ooh, that would do everything. That's true. Yeah, because we're doing the not, so. But if we wanted to just do that to, it would just show. Instead of, well, I guess I could just comment it out. I need to get better at just commenting out code. Then we do this to remove it. Cool. Yeah, I never comment code out. I need to, because it's hard to, you can't do it in Unreal, I don't think. I can add like a breakpoint to check, but here it's way easier. Why are they equal? Well, yeah, De Morgan's laws, but okay. If we distribute or not, the sign flips. Yeah. Okay. Yeah, I need to just get home from work and then just fucking sit here and then just do this till basically bedtime. Because in 2 years, I want to be able to get paid for this kind of stuff. And I want people to be like, oh, wow. Yeah, you know that for sure. There's no question. You're not like just fumbling your way around. All right. More than 6 hours of work, I'll take it. I needed to do at least 6 today because I only did 2 yesterday. And I want to be doing at least 4 a day, 4 hours of coding. That's 28 hours a week. But really, it should be even more. I want it to be like 5 maybe. But like, how much time do I have again? Is it 5.5 hours after work? So if let's just say I get off work at 5. So I get home at 5:30 after traffic. And then let's say it takes me an hour to be showered and eat and whatnot. So 6:30 until 11. It's only really 4.5 hours total. Really? But that's if I go to bed at 11, which I should be going to bed at 11. So really, yeah, that's 4.5 hours. That's as much as I can dedicate. On weekends, I should be doing more. I'm going to try and commit to like another 2 hours or something today. Because now this isn't aversive. At first, it was like, I don't really want to sit here and do this forever. It's hard to get here. But now that I'm here, it's like, I mean, part of me just wants to sit here and continue on these, but my brain needs a rest and I can feel it. So on weekends, I'm going to start trying to do like 6 hours and then 8 and then more, but let's just say 6 for now. So next weekend, I'm going to do 6 on Saturday and Sunday. So yeah. Yeah, so to go from 28 hours a week, so 4 a day, 4 times 7, to instead that. Well, in 4, that assumes no time spent. So yeah, that's what I'm going to try and do. I'm going to try and get home and within an hour have eaten and chilled out, to no more chill during the day, and then just work and then game dev. I still need to do game dev at some point too. So I'll probably just end up doing that before bed. Maybe I do more coding, but we'll see. So 30 minutes of that before bed. That'll be good. Once I brush my teeth, I'll do that. So, okay, more coding tomorrow.